Hi, I am Dr. Rafdzah Ahmad Zaki, a professor of epidemiology and public health at the Department of Social and Preventive Medicine, Universiti Malaya. This video is my entry at the Malaysia Technology Expo 2025, where I will present our project on dengue severity prognostication using artificial intelligence, or the DeSProg study.
With dengue incidence rising globally, affecting about half the world's population, Malaysia remains a hotspot with significant healthcare demands during each epidemic. Though most cases are mild, early identification of high-risk dengue patients is crucial to prevent severe outcomes. Our project was approved by the UMMC Ethical Committee. The prevalence of severe dengue among hospitalized patients is between 4 to 6%. But with an increased number of dengue cases, the number of patients requiring hospitalization and developing severe dengue is also increasing. The critical phase normally develops between 3 to 7 days after the onset of symptoms. During the 24 to 48 hours of the critical phase, a small portion of patients may manifest sudden deterioration of symptoms. The complexity of the clinical profiles and the overlapping levels of factors makes the structure of clinical data complex and difficult for a clinician to predict severe dengue. The use of machine learning as a tool to identify the possible characteristics is a potential solution and can be used to predict severity in dengue patients. Our team includes diverse expertise, united to tackle dengue severity prediction. We developed a machine learning-based system with input from dengue expert, infectious disease specialist, AI expert, biostatistician, and epidemiologist. Our project has 3 phases. Phase 1 is the development and validation of machine learning-based risk scores for severe dengue prediction. A total of 580 cases were collected and 263 cases were finally included in the analysis, with 12 cases later developed into severe dengue. We developed prediction models using 3 machine learning algorithms: logistic regression model, random forest model, and 1 class support vector machine model. These algorithms provide calculation probability methods or functions that map the predictor value to a corresponding probability between 0 and 1. With data from 263 laboratory-confirmed cases at UMMC, we compare the model derived using data from patients presented between day 1 to day 5 of the onset of the symptom, and the model derived using data from patients presented on day 1 to day 4. A total of 88 predictors were available, which consisted of demographic information, past medical history, symptoms, laboratory results and ultrasound findings on the first day of patient enrollment. The model with the highest balanced accuracy was the logistic regression model with 80% using 10 features. They were the presence of urine ketones, abdominal tenderness, body aches, chest discomfort, pleural effusion, ascites, serum lactate, serum creatinine, pre-hospitalization consumption of ibuprofen, and BMI value. Phase 2 involved creating the DeSProg prototype, featuring a dengue electronic clerking form, severe dengue prediction, and a dashboard to display dengue statistics. The system also will serve as the dengue database at the hospital. The e-clerking form includes sections on the admission clerking form, daily review form, and discharge form. The dashboard displays patient data, offering clinicians an overview of the patient's health summary and the trend of the clinical variables during the hospital admission. The Patient Health Summary module provides a detailed overview of the patient's medical history and clinical assessments throughout their hospitalization, presented in a concise time series format. In Phase 3, we tested the system in a clinical setting, allowing direct data entry to the e-clerking form, which enables real-time severe dengue prediction based on current patient data. The system will automatically predict the probability of developing severe dengue or the probability of non-severe dengue as the outcome. During our testing period, between November 2021 and November 2022, we had 307 adult dengue cases at UMMC, with 270 complete data entries. We compared actual outcomes diagnosed by the infectious disease specialist with model predictions. Out of 270, 10 were classified as severe dengue by the clinicians. Using the probability of severe dengue greater than 60% as the cutoff value, 21 of patients were classified as severe dengue by the prediction system. The accuracy of the system is 91% with a specificity of 93% and a sensitivity of 30%. The positive predictive value is 14% and the negative predictive value is 97%. In summary, the DeSProg system, incorporating a machine learning technique, demonstrated promising results in predicting the risk of dengue patients progressing to severe dengue in a clinical setting. The high specificity and negative predictive value enable precise identification of patients at low risk for severe dengue. This accuracy can help minimize unnecessary interventions and reduce the number of dengue patients requiring intensive monitoring by clinicians, optimizing healthcare resources and improving patient management. The DeSProg system streamlines inpatient dengue data collection, building a valuable database for analysis and prediction. The automated data entry enabled by our e-clerking form facilitates continuous data gathering, leading to model improvements over time. While the system could assist clinicians in early prognosis and management of hospitalized dengue cases, further improvements in sensitivity are needed to better identify high-risk patients who may develop severe dengue. The DeSProg system holds the potential for advancement into an automated machine learning system capable of addressing different phases in the machine learning process. In the long term, we envision a future where DeSProg significantly reduces dengue morbidity and mortality, enhancing healthcare for dengue patients across Malaysia. Thank you.